Hi everyone. Hi everyone, and welcome to All Around Azure, a developer guide to IoT. I am Valeria Savenko, IoT product manager based in sunny Brisbane, Australia. A few things before we get started. During the event, please be friendly and welcoming, patient, thoughtful, and respectful towards one another in the chat. We have a very busy agenda today. The event will go for 2.5 hours, and we're going to learn how to develop real-world Internet of Things solutions built with Microsoft Azure services from experts all around the world. To kick things off, I'm super excited to have Oliver Block and Sam George as our keynote speakers. And over to you, Oliver.
Hello and welcome to the first virtual All Around Azure IoT event. That's your getting started on IoT technologies and on your way to getting certified. And today, joining me, I have Sam George, our CVP for engineering for Azure IoT. I am Olivier Block. I am a technical PM in the Azure IoT engineering team looking after communities. How about you, Sam? Give us a little introduction about yourself.
Yeah, Sam George, been at Microsoft quite some time, former developer myself, so developers are very near and dear to my heart. Thrilled to be with you today.
Thanks, Sam. So today, Sam would like to give you a little bit insight about why you should care about this event. Why would you want to become an Azure IoT certified engineer, and why would you want to go through the topics that we have today for you? But before we go there, think about this event as your launch pad on your way to becoming certified for Azure IoT. You'll get some learnings today about how to connect the device all the way up, how to integrate with business application, how to bring ML at the edge and apply on IoT data. But all of that obviously is in the context of how the business is evolving and how things are growing. And so, Sam, what about the ecosystem and how is the landscape looking these days for IoT?
Yeah, well, one of the great things about being a developer in IoT now is that businesses around the world have recognized the benefit of IoT. IoT gives you visibility into all physical aspects of your business in real time, and businesses just didn't have that insight before. But at the same time, it requires a pretty sophisticated level of development, everything from embedded development to edge computing to cloud solution development to biz app development, and everything that we've been working so hard to provide over the last 5 years makes that easier and easier and easier. So there's really never been a better time to be a developer in IoT. The technology's ready, and there's a tremendous amount of demand for developers in IoT.
Yeah, and what's interesting is, so not only IoT solutions span from these devices all the way up to the business applications, and that means that you have different types of software engineers that need to be involved, to build the device on one side, to connect it, to work on the networking, on the security, but also on the web side of things, right? The dashboarding and the use of the cloud services backend. So lots of different software engineers are not involved. So hence one more reason for people actually to learn about IoT, even if their background is not embedded development. There's also a dimension which I find really interesting in what we're evolving, is that it's not just software engineers. Now you need to work with data scientists. You need to work with, chemical or physical or mechanical engineers. So it's pretty interesting. And, in that context, Sam, I'd like for you to get people excited. If they're not familiar with IoT applications and solutions, what's your favorite IoT solution out there?
Well, it's hard to say one particular favorite. There's so many that are happening right now, but one of them that I'll talk about briefly is one by a great company in New York City called RXR Realty. And they've developed a solution that as people are coming back into their buildings, into offices, to help keep people safer in this time of COVID-19. And what it really shows, what this RX Well solution, they call it, shows is how IoT, edge computing, AI, and cloud can really help provide solutions that help keep people safer. So what RX Well does is it uses cameras running our edge computing platform, IoT Edge, that are mounted in various parts of the building, as well as sensors. And what it does is it ensures that, number one, people are wearing masks, that there's ensuring safe social distancing, they're staying 6 feet apart or not. that different parts of the building aren't being overly crowded. There's not too many people in one particular area. It's also tied into the building infrastructure itself. So it ensures that there's high airflow, for example, in the building. So all of this winds up meaning that instead of having to go around and manually ensure people are wearing masks and safe social distancing and things like that, that the building tenants and the administrators just start getting alerts when they're not. And then they can go and help, just sort of remind folks to be safe. So all of this is combined then to help really keep people safer in an automated fashion. And it's a great testament to the power of IoT and edge computing and AI all working together.
Nice. And so actually it makes me think, can you give us a little bit insight into what is it that Azure IoT is providing? So customers are implementing these end-to-end solutions, but how do we contribute? What is our role in all of that?
Yeah, so let's talk about the RX Well solution, and I'll talk about just briefly the different areas. We provide everything in the cloud. So we have our Azure IoT Hub cloud service, which is used for connecting to and managing those millions of devices, sending trillions of messages. We have data services, we have business application integration services. You'll hear all about those today. But then out on the edge, we also have our edge computing platform, Azure IoT Edge, that helps developers run cloud services such as AI workloads directly on devices themselves, as well as SDKs for running on devices themselves, down to the very tiniest of devices. So we have Azure RTOS that runs on devices with as little as 50 kilobytes of memory. We have Azure Sphere, which provides a safe and secure endpoint that's monitored by Microsoft and always up to date. And then we have a device SDK that runs on virtually every operating system in IoT on the planet, in every language popular language developers are using today. All of that is open source and broadly supported by our team.
Nice. And on the cloud side of things, we talk a lot about integrating with business applications and so on. So how does that work up there?
Yeah, we make that super, super easy with offerings like Azure Logic Apps, as well as Power Automate. So those two tools, services, I should say, Power Automate and Logic Apps, provide connectors to well over 250 business integration systems, and not just by Microsoft. Lots and lots and lots of different services, SAP, Salesforce, and on and on. And so as a signal is detected in the physical world and you need to alert some business process, we make that really, really easy to integrate with.
Nice. And in our goal to simplifying IoT, so we're building all these Lego blocks, right, to build your own solution. But we also are offering IoT Central, right? Can you give us a little bit, of insights about what is IoT Central and what is it meant for?
So all of the different almost building block platform services that I just covered so far, you can assemble them just like RXR did into these solutions that help fuse the physical world and the digital world and provide insights in real time. What we've learned in our time in market is that not every company has the development skills that are required to do that. And so what we've done is we've put together an offering called Azure IoT Central. And what Azure IoT Central does is it uses all of those different cloud services that I was covering and more. But it puts it together in a very simple to use SaaS offering with a super predictable price per device pricing that gets cheaper and cheaper the more devices that you use. You don't have to worry about assembling those cloud services or scaling them up independently. You simply connect devices to it. You can connect devices in just minutes. And as you add devices, Azure IoT Central uses all of those services, automatically scales up. It provides out-of-the-box rich dashboards, analytics, and then also business process integration. So it takes advantage of Power Automate Logic Apps. It has continuous data export, so you can export all of your data on an ongoing basis from IoT Central to downstream Azure services. So we've made it super easy. We like to say that IoT Central enables you to connect devices in just minutes, go to production the same day, and scale to any amount of devices, all without needing cloud solution development skills.
Yeah, I've been pretty amazed by the amount of features that are now in IoT Central. Actually, one that is super important for our developers is the APIs that IoT Central exposes. It's not a black box. It's something that you can
Right.
develop with and around and integrate into your solution end to end.
That's exactly
Sam,
right.
what about what's coming next? What's the vision? Where are we going with all of that?
Yeah. So if you step back and look at what's happening in the industry right now, IoT has really gained mainstream adoption over the last 5 years. And the primary use of IoT has been to find insights from, you can think of it as insights from assets, right? HVAC machines or water pumps or elevators, to find the maintenance needs, to predict those maintenance needs, to gain insights from those. But it's really been geared towards the assets themselves. And what we're starting to see now in IoT is that as IoT becomes more and more mainstream, that companies are wanting to connect entire environments. So, for example, I'll pick on manufacturing. They're interested in not just connecting to the manufacturing assets, right? The bottling machines or the milling machines or the welding machines. They're interested in connecting to the entire environment, the building itself, all of the people that are in it, the inbound supply chain, the outbound distribution network, and to find insights from that entire environment. And so just late last year, we made generally available Azure Digital Twins. And what Azure Digital Twins is it enables you to model entire environments. So you can model them first. Then you can connect IoT sensors as well as other business signals to Azure Digital Twins. And what Azure Digital Twins does is it effectively builds a live distributed object model that represents that physical environment. And then it enables you to data bind to the physical environment. And then as the physical environment changes, Azure Digital Twins raises events, you handle those events, you implement business logic. So digital twins is really the next stage of the evolution of these connected solutions. And then just over the horizon, we start to see businesses starting to partner over the insights that they gain in these connected environments and to provide really, intelligent ecosystems that will all work together. So it's an incredibly exciting time. We made it really easy, and it's a great time to be a developer in IoT.
Nice. Yeah, and actually interesting you mentioned digital twins as the hero next big, feature or service over here, because I've seen actually lots of different types of engineers
Yeah.
very interested in the use of digital twins. Like when you come from a different background, you're not a software engineer, you need to have this level, this graph that allows you to rapidly ingest all that data from various sources. And you don't want to build or having to build these blocks, these things that are not,
It's
there.
complicated plumbing. It's hard to get right. It took us several years to get it to market because
Yeah,
it's so complicated. But what's nice is that now we've simplified that, and you can simply model in a very flexible language we call the digital twin definition language. You can simply
yeah.
model that any environment, the relationships between things. Send that to Azure Digital Twins, and we'll materialize that distributed object model for you.
Like that, like that. What are we doing to simplify how solution developers connect devices? Like, I know devices is something that is complex by nature. Also, when you want to connect devices from various types, various manufacturers, various places, well, they all come up with their own protocol, their own language, their own way of exposing their data. So what are we doing in that space to help developers integrate their devices with the devices from other companies, partners, whatnot, into their solutions?
Yeah, well, one of the challenges that we saw over the last 5 years in IoT is that there's this incredibly tight coupling between software that runs on the device and software that runs in the solution. So as an example, if your device is hard-coded to send temperature and humidity and vibration, your cloud solution has to be hard-coded to receive temperature and humidity and vibration. And often there's even an expectation about how frequently it sends. And so, in early IoT, honestly, that wasn't a problem. But what IoT is starting to bump up against is that device providers are now wanting to provide devices that can be used generally in lots of different solutions, not just one. And Solution providers are wanting much easier onboarding experiences for devices where they're not effectively having to just go down to bare metal on the device and hard code a bunch of sensor information that's coming from the device. So as part of our push last year on digital twins, we introduced and made generally available what we call IoT plug and play. And what IoT plug and play is very simple. It uses the digital twin definition language to help developers, device providers, explain or to attest what capabilities the device has, what telemetry it sends, what state that it can synchronize, what commands that it receives, and the responses that it sends from those commands and things like that. And that's all packaged up in the digital twin definition language for the device that uses the digital twin definition language. Now, when the device first connects, it sends a pointer to its document for this digital twin definition language document. And then the solution can simply automatically adjust to what the device can do. So we showed a demo, and I think we'll be showing that as part of this series, showed a demo where you can simply take a device that Azure IoT Central, for example, has never seen before. And as the device is connected and goes through our device provisioning service into IoT Hub, which is being used by IoT Central automatically shows a dashboard for the device. It shows all the different data fields that the device is sending, the telemetry, any of the state that it can synchronize, the commands that it can receive, all without writing a single line of code in the cloud to configure it. So it's a super powerful way, effectively, to program IoT devices.
Love it. Love it. Well, I hope that we have everyone's attention here. Before we wrap up, Sam, besides having us learn to work remotely and record this kind of events online, right, and also deliver that to more people where, from the home, do you see any impact from COVID and the pandemic on the IoT business itself?
Yeah, for sure. In fact, we've seen an acceleration. Most companies, we do this signals report. We call it the IoT signals report, where we go and survey businesses from around the planet, about 3,200 different businesses. And what we're seeing in general from all of those businesses is that for businesses that were getting started with IoT or that already had an IoT solution, IoT has in fact accelerated. It's much, much, much faster. Now, of course, some of the businesses where they were lights out, where they weren't able to get to, they hadn't done that, an IoT solution yet, and they were unable to get to their physical premises, of course, that had an impact. But even there, we're starting to see return to work and people getting going. So all up, it's really had an accelerating impact on IoT. So again, another great reason to be an IoT developer.
Yeah, so time to wrap up. Thanks, Sam, a lot for your time and your insights. We really hope we have your attention and that you understand how important having skilled IoT engineer is for the business these days. It's really for you an opportunity to grow in your career. We have a bunch of content for you today, but once again, do not stay at just the event of today. We consider that as your launchpad to becoming an Azure IoT certified engineer. And so for that, we have a 30 days to learn it challenge, which is available for you at this link. And what that is a set of self-paced, IoT learning courses that you will have to go through. And if you make it in these 30 days, you will receive a 50% off on a Microsoft IoT certification exam. So I think it's really worth it. And once again, on your way to becoming certified, do not forget to sign up. It's this link or at the bottom of the All Around Azure event. Sam, once again, thanks a lot for your time. Enjoy the event today, and I hope to see you soon. Bye.
Thanks, everyone.
What a great start to the event. Thank you, Oliver and Sam. And up next, we have a session on connecting a physical environment to a digital world, a roadmap to IoT Solutioning by Jason Frankel. Jason is a software architect at Telstra, leading digital twins and IoT-related strategy, services, and solutions. He works closely with Telstra and its customers to shape their strategy. This position, his experience with the US Defense IoT solutions, puts him in an extraordinary position to see what's coming up next down the line, and most importantly, to share what's possible from Telstra's perspective. I'm looking forward to your session, Jason, and over to you.
Great, thanks, Val. So hello, and welcome to Connecting Your Physical Environment to a Digital World, roadmap for solutioning, IoT solutioning. So again, my name is Jason Frankel, and I'm a principal consultant for Telstra Purple, which is the largest sovereign consulting organization within Australia. In this session, I'm going to briefly go through an introduction to IoT, as well as Microsoft's Azure IoT offering. And then we're going to talk a little bit about a specific concrete solution, and then a little bit about digital twins. All right, so let's go ahead and get started. So first, a little bit about me. I've been building distributed solutions, IoT, MDM solutions, my entire career since about 1993. Got to work with some really smart guys in this area. So I'm looking forward to sharing some of my experience. All right. So first, what is the Internet of Things? Well, the Internet of Things comes down to four things, essentially. Physical things, connected things, and that's things that are connected either via the Internet or to other things or even to people. Communicating things, these are things that collect and communicate information about the environment, systems, or other users. And then analytics on the resulting data so that people or systems can actually act on the information that's coming in. So IoT has been the innovation that enables new opportunities for quite some time. But with the introduction of cloud computing, IoT devices can now be connected globally. They can also be available pretty much all the time with unlimited compute resources. These resources can harness signals from a variety of different sensors, devices, and equipment, which can be managed centrally by the cloud. And then new advancements in edge and AI can now offload that intelligence to the edge so that only the necessary information that's needed is transmitted up to the cloud. And finally, digital twins. This is my favorite area. Digital twins represents an unprecedented opportunity to create live replicas of any physical environment and to do so incrementally. This goes beyond tracking the past to really predicting the future. So given my work and my organization's work with our customers, we've learned quite a bit in this area, both in IoT and digital twins. And we've seen customers realize pretty significant benefits from using IoT as well as digital twins. And what we want to call out, want you to take away is really that if this isn't done right, you can really end up with some long timelines. It can be simple to do a POC, and you can actually do it in a few months. But with Microsoft Azure IoT services, you can scale it pretty easily from that POC. It's also can be very difficult to test at scale. When you have so many devices and so many analytics going on in an IoT system at scale, it can be difficult to get all the different permutations and the testing that you need in place. And lastly, no good IoT solution is worth its weight if it doesn't actually integrate with your business systems and can't be customized as your business needs change over time. So let's show you how we're solving some of these typical obstacles. So with Azure IoT services, Microsoft actually presents a pretty comprehensive solution. It allows you to design scalable IoT solutions easily, whether it's a few hundred devices or a few hundred million. And then it allows you to scale them quickly and with relatively minimal changes. So IoT services include, Azure IoT services include device connectivity as well as device management. It includes data ingestion and command and control. By command and control, I mean you can actually talk to the devices and tell them to upgrade their firmware or to do other things. also includes stream processing and predictive analytics. So as data is coming in, you can change it live. You can augment it with other information, modify it, do prediction, or even detect and trigger a workflow. And that leads us to workflow automation. Like Sam mentioned, logic apps or Power Automate can be triggered pretty easily. And that lets you kick off work or activities in completely other areas. It also provides dashboards and visualization, both through IoT Central as well as Power BI. And then it does provide you some out-of-the-box accelerators for building some pre-configured solutions. One of the things that my organization does is we provide a set of APIs for taking existing vertical line applications and extending them even further, building on top of these services. So let's take a look at a simple example. So what better example than to build a better mousetrap? So there's actually a longer session. I think it's about 45 minutes that actually goes through and develops this solution. And today we don't have that much time. We're gonna just go over it at a high level. So if you think about this new IoT mousetrap that we're going to create, essentially the opportunity is that the rats and vermin spread a lot of disease, and traps need to be monitored with people. People need to walk around regularly and travel to check the traps, whether they're empty or not. A uncleaned trap or an unchecked trap can result in a frustrated business owner or frustrated customers. And I tried to check the numbers on this market size. The market actually varied pretty substantially between about $40 million a year and $12 billion a year. So let's go with 12 billion. So one of the nicest things about working with Azure IoT services is that they have a great reference architecture, and it's really easy to digest. It gives you a nice starting place, and the further you get into it, the further it goes into larger solutions. So you can really start simply. This small solution actually fits this reference architecture pretty nicely. So on the left there in the green, you can see we have our mousetrap devices or devices in general. Then we have our cloud gateway. Then we have stream processing and storage in the middle, as well as reporting tools. And then on the right there, we have business integration. And that's where I was talking about triggers happening and then linking up with logic apps or Power Automate. So what would our solution look like here? So our IoT capable devices over here on the left in green, these would be, I think, a relatively simple embedded device. Those talking up to Azure IoT Hub, which is their primary service for working in IoT. And then using stream processing, using a service they have called Streaming Analytics, storing that data, and then reporting on it. It will provide a little bit of machine learning and also a little bit of business integration via a mobile application. So this is the resulting solution, system architecture for that. On the left there, you'll see a trigger. This is a simple sensor on the trap, a small Raspberry Pi running a Linux implementation, say a .NET Core app. We also need to build a small simulator to generate test data so that we can test this solution. Like I mentioned, that can be difficult, so it's important to do that. And that data gets fed up to that Azure IoT Hub gateway. From here, scalability becomes very easy. Also, managing the devices becomes pretty easy. The data comes in, it streams right out. You you essentially connect it up to streaming analytics via the Azure portal. From the streaming analytics, we're going to stick it into a SQL database. And then that database becomes the source of truth for the data for reporting and analytics in Power BI. A little bit of machine learning. And then that gets displayed in a mobile app via embedded Power BI. So the solution is actually available online in a GitHub repo. There's a lot of artifacts available there for you. So I'd encourage you to go to the link shown on the screen and take a look at it. It's got a lot of information that'll make things easy for you to get through to build out the solution. So we can take the solution a bit further now that Power BI includes Azure Maps. Let's say that as we deploy these mousetraps, these IoT mousetraps, we record the location where they're deployed. Now we have enough information to map the data coming in to an actual map, inside map, or in-building map. So this allows us to get some nice visuals to give us a quick indication of when traps need to be cleaned. It can also help us to avoid exceeding an SLA with a customer because we didn't clean the traps in time. All right, so now my personal favorite topic. So how would we use something called digital twins with this solution? So we've heard a lot about digital twins, but how does it apply, really? So first you have to think about what would you do to take that solution, that mousetrap solution we just looked at, and scale it? And where would you scale it to? And to what would that mousetrap actually relate? This is where digital twins comes in. It's kind of like the glue that pulls that mousetrap in and allows you to connect it up with other solutions easily. So digital twin, the term, has been around for about 30 years in science fiction. It's first coined by David Gelernter's book Mirror Worlds. Historically, digital twins have essentially been data warehouses. They're like a small reporting warehouse for either a asset or for a project that are only updated maybe daily or weekly. Today, digital twins are real time. And this makes it easy to incrementally build out IoT solutions over time. This makes it so you don't have to figure out this big bang, type delivery. You can incrementally deliver based on value. So what would that look like in our solution? So in our solution, we could create a digital twin for the mousetrap. We could create one for the floors, or for each floor. We'd also create one for each building that they're deployed in. And then we set these up in a relationship so we can get reports on the building to know, how many traps need to be cleaned for that building. Or we can get reports on the floor to know how many traps need to be cleaned for that floor. It makes things much simpler, and it makes it so you can keep working with this without having to rebuild it over time. So how would that look, and how does that data actually come in to digital twins? Well, I tried to come up with an architecture here where these small IoT mousetraps might use an edge gateway, like Sam mentioned earlier. Azure IoT Edge could be deployed right there at the edge, and then act as like a gateway to push up the data into Azure IoT. That data would then flow right into Azure Digital Twins. And that as the data flows in, it updates what we call a twin graph, so that's a bunch of different twins that might be related to one another. And it's important to remember that as you scale this out, that these twin graphs can get very complicated. And this is a pretty interesting area right now. This is all real time, so keep growing and growing and growing. This is a pretty interesting space. So the solution we just looked at could be repurposed for a variety of different things, but I like ice cream, so let's repurpose it for an ice cream truck. So we could, let's say that we took the trigger in the mousetrap, we replaced it, or structured it so that it would actually trigger when the ice cream truck stops moving. So then once we know when the truck stops moving, we can start to record the orders that were taken during that time. And that gives us some pretty good value, because now we know what orders were taken, at what time, at what location, and we can plot that over time using Power BI. We can get an idea of how productive different routes are for the ice cream truck driver. So there's a bunch of resources that Microsoft's made available to us to help us out to get going in this area. First, you can find quite a bit at the Session Resources Hub, as well as Microsoft Learn. You can find all of the code and a bunch of other assets and examples on GitHub. And you can find all of the event session resources as well at the link shown at the bottom there. So there's complete interactive learning available now. You can go at your own pace. There's a bunch of different modules that you can go through. We've had quite a few folks at Telstra Purple go through this, and it's fantastic. I think we've had 14 or so that have actually gone through it successfully now. We started about 3-4 months ago, and that's just one squad. They also have a new digital twins set of learning as well, I was told about. I believe that's available on there as well. You can also get certified in your AZ220 certification. This is a great accreditation. It's pretty thorough. Test is pretty reasonable. I don't think it includes digital twins yet, but I expect that it will in the fairly near future. You can go to that link shown there to get more information about the certification. Yeah, and so there's lots of free interactive learning content. You should go check it out at Microsoft Learn. Begin looking at this stuff. It's actually really easy to do. It's very easy to get started. I really encourage you to take a look. Thank you. Again, my name is Jason Frankel, and thanks for attending this session.
Thank you, Jason. Such a great overview. I've read the other day that over 80% of the world's data collected, I think it was estimated that 32 billions of connected devices generating the data, which is an enormous amount. And I know many organizations are trying to capitalize on this for the purpose of automation or estimation and require a starting point to do this. So thank you so much for sharing the IoT real world adoption scenario with the audience. I've learned personally a lot as usual. And we do have a few questions. I know you've spoken about Azure Digital Twins, and you even said that it's one of your passion points. Do you mind sharing, what sort of value deploying digital twins bring to our customers?
By far, the biggest value that I've seen so far is it gives us a great place to start quickly. So normally you have to figure out where you're going to end up exactly long-term, with your solution. Well, now with digital twins, you kind of set up the digital twins, and then you start implementing little project by little project over time. You don't have to have this grand vision and view of what you want your solution to look like. So it's fast for our customers to get started.
Yeah, and you've mentioned, we have, usually when we talk about IoT, it's millions and millions of devices that connect to Azure. And I'm just wondering if you can share some of your experience with the audience around how do you go about testing that at scale?
Oh, that's a great question. So there's relatively simple techniques that can get you a lot of the way there. we mentioned building a small data generator for the Azure mousetrap or the IoT mousetrap. So that's one way. For more exotic solutions, you can make those data generators a little bit smart, so you can control them from remote. You get kind of this command and control thing going up for the simulated devices, so that you can then put test cases on top of that. You can do things at scale.
Awesome. Well, I've learned a lot. Thank you so much for your time and jumping in today. Please follow Jason on Twitter. You see his handle at the bottom. And thank you for your time.
It was my pleasure.
And before we jump into the next session, make sure you have a look at our 30 Days to Learn It IoT Challenge at aka.ms, 30 Days to Learn It IoT. And all the learning material on the event, including the slide deck, is at that link, aka.ms/IoTLP/blog. And up next, we have Deciphering Data, Optimizing Data Communications to Maximize Your ROI. And I'm super excited to have a good colleague of mine, Dave Glover, today. Dave Glover is a cloud advocate at Microsoft, passionate software developer covering a broad range of technologies from Windows to mobile to dev. And he's curious by nature and loves to learn and connect with the developer community. I'm super excited to have you, Dave, here with us today and looking forward to your session. And over to you.
Awesome. Thank you, Val. Hello, and welcome to the Deciphering Data session. My name is Dave Glover, and I'm a cloud developer advocate based in Sydney, Australia, and I've got to focus on the Internet of Things. Now, in this session, we're going to have a brief introduction to IoT. Now, I appreciate that this was already covered in the previous session, so it is going to be brief. We're going to discussion around IoT data architecture, and we're going to look at some common data patterns for processing IoT data. Keep in mind that there's also an extended version of this module that delves into how the solution can be implemented, and you'll find the link to that session in the set of resources in the back of this session. So let's go ahead and get started. Alrighty, so innovation and commoditization are really driving tremendous growth for IoT solutions. So if you think about it, with cloud, we've got nearly kind of unlimited compute and storage resources. We can connect nowadays vast numbers of devices, and there are amazing breakthroughs for AI, so both running AI in the cloud and also offloading it onto the edge. And with digital twins, we can map the complexity of the physical world using virtual models to address more complex problems. So this digital transformation offers opportunities to understand how our products and services are being used in ways that we could really have dreamt of in the past, and change the way our business operate, how our cities operate, our environment, our governments, and ourselves, of course, with wearables. So the context for this talk is going to be around smart factories. And more specifically, we're going to focus on the monitoring of these four aspects. So we're going to look at monitoring HVAC systems. So an HVAC is a heating, ventilation, air control, and air conditioning system. So it's the kind of thing you find in your home, in your office, obviously in the factory. And the idea behind the HVAC system is we want to be able to maintain a comfortable and healthy working environment. Now, in this factory, we've got machining tools, and we're going to specifically look at a lathe. Now, if you're not familiar with a lathe, it's something that spins very quickly, and it's used for performing various operations like cutting, sanding, and drilling, and things like that in the production process. We're going to be looking at production line quality process. We're going to talk a bit about how we might do that. And we're going to look at monitoring, how we might monitor raw materials. So that's going to be, as I said, the focus of this is going to be really around smart factories. But what I really want to emphasize is the reality is that this session and this architecture are really applicable to most IoT solutions. So really the typical architectural high-level solution, high-level architecture of an IoT solution is really made up of three components. So we've got things that generate data, and we talked about those previously. They could be devices that are monitoring the temperature in the factory, for example, or maybe a device that's monitoring a manufacturing process. We've got insights. Now, insights are based on data, are generated from data. And then we've got actions, and then actions are based on the insights. So for example, you might want to turn off the heating and lighting as there's nobody left in the building, or maybe notify the maintenance center that a machine needs attention because it's not performing to spec. So what we're going to do now is just go into a little bit more detail and kind of cover these scenarios, each one of these things, insights, and actions. So we're going to start off with things and step through several scenarios, really starting with the simplest. The first is a device that's going to be monitoring this HVAC system. So remember, the HVAC system is this heating, ventilation, and air control system, air conditioning system. Now, in this case, this device that's monitoring the HVAC system has enough processing and memory capabilities and memory resources to be able to establish a secure connection and authenticate against a cloud gateway using standard internet protocols. Now, the device generates messages. When these messages broadly fit into two categories, we've got telemetry messages, and they typically contain sensor data, so like temperature, humidity, things like that. And we've also got alert messages. And alert messages are more about events. So for example, an emergency button was pressed, and maybe someone needs to find out what has actually happened maybe on the factory floor. So we've got our data and we've got our messages, telemetry and alert messages. Now, before that message can be sent to the cloud, it needs to be serialized. And the approach to serialization really depends on a number of factors. It can depend on things like the network bandwidth you have, or maybe the data type. Are you sending text or simple fields, or are you sending more larger binary fields and things like that? And those can impact on the way, the kind of the best serialization format to use. So for example, data types such as temperature and humidity readings, often using a text-based JSON approach is best, particularly because a lot of backend data systems natively support JSON data types. You don't have to do any additional work. For larger binary data types, such as a photo, for example, it often makes sense to use a binary serialization format. And the two that are commonly used are Avro and Google Protobuf. But you've got to keep in mind that if you're going to serialize these messages into these binary formats, like Avro and Google Protobuf, that you will need to deserialize those messages when they get into the cloud. So there's more additional processing that needs to be done. But that's typically the way you kind of deal with more complex messages or larger messages. And before you send those messages out, it's really important that you add metadata to these messages. So metadata is kind of data about data. In this case, it's data about the messages. And it's really important to include this. And the type of metadata that you might include might be saying, hey, look, this message is a telemetry message, or this message is an alert message. What serialization format am I going to be using? Am I using JSON? Am I using Avro? Am I using Google Protobuf? Is this what is the schema I'm using? And schemas, as we know, change often or too often. And it's really important to know that, okay, this schema, or that describes the shape of this data, maybe this is schema version 1. And when we process it up in the cloud, we know that we're dealing with schema version 1, but you might have another version of a schema, and you need to do that. So by adding in this metadata, as you hopefully can tell, it makes processing in the cloud much simpler. So you've got this message, you don't have to open up the message. You can look at the metadata and say, this is formatted in JSON, it's a telemetry message, it's schema version 1, and this is a serialization format. So those are the kinds of things you need to think about. So as I said, this is kind of like the simplest. I've got a device with enough capability that can directly connect to a cloud gateway. Now, the next thing I want to talk about is talk about gateways. And gateways enable IoT communications across domains. And they broadly fall into two categories. We've got field gateways, and we've got custom cloud gateways. Now I'm going to talk about field gateways first. So you'd most likely use a field gateway when you need to integrate constrained devices that don't have enough resources, be it CPU resources or memory resources, to be able to establish a secure IP connection to a cloud gateway. The other thing about field gateways, and kind of a bit by name, is that field gateways are also normally co-located with the constrained devices. And an example would be on the factory floor where you've got these devices that are constrained devices. They will be able to talk directly to this field gateway. Now, you might also need to be able to convert to industry-specific protocols. And there's a couple there like OPC UA, Modbus, and CoAP are often protocols that have been used in manufacturing sector. And if you think about the manufacturing sector, they've got a really long established micro or embedded controller history that really predates kind of internet protocols. So in this scenario, you would use a field gateway to convert those more industry-specific protocols into internet protocols. And it gets more widely adopted standards, both for security and for message formats. And the idea is that this gateway, this field gateway, will send and receive messages on behalf of the constrained devices. Okay, so the second type of gateway is this thing called a custom cloud gateway. Now, a custom cloud gateway integrates devices with different cloud networks. So a great example would be you might want to monitor raw materials for a manufacturing process. And now these raw materials might be stored a long way away from the factory, and in fact may be stored in locations where there isn't good internet access. So a solution to this might be to use something like LoRaWAN and use it where LoRaWAN is a great protocol which is geared towards long distance, low power transmission, really of small quantities of data. So you can use that plus a custom cloud gateway to breach the data from these, in this case, the raw materials, and have that information going over LoRa network, across the things network, and into a custom cloud gateway. And look, the same is true for things like Sigfox and particle networks. Very similar process as that you'll go and use these kind of concepts of custom cloud gateways. Okay, so the next scenario I want to talk about around on the things is the idea of intelligent edge devices. And I want to talk a bit about why you would use these and kind of come up with these reasons. So the first reason is where you're dealing with where a low latency response is critical, and that what we said, the time value of data might be measured in milliseconds. So for example, a lathe. Now this lathe may be generating a lot of data, and let's say a bearing breaks, for example, and this sensor figured out that this lathe is now vibrating. Now, if you were to send a message up to the cloud to say, hey, look, there's a problem with the lathe, and then you've got a machine learning model in the cloud saying, yep, there's a problem, I think you should stop that lathe, and it sends a message back down to control it, to turn it off. By that stage, it might be too late. And what you might have is the lathe might have spun off into thousands of pieces, which would obviously be very expensive to get fixed. So the idea here is that if you deploy local intelligence, you can have a device which is monitoring that device and then making decisions for that device locally, and then just sending an alert message to the cloud to say, hey, look, there's a problem. And the analogy I like to use is our own peripheral nervous system. If you think about if you go and touch something hot, then you know you immediately put your arm or put your hand away from something. That's called the reflex arc. And what's happening is a process is happening in the nodes in your spine, making a very quick decision to twitch that muscle to pull away your arm, and then sending a message to your brain to say, hey, look, there's been an event happened. So very similar kind of concept. And really the third reason, the second reason would be local stream processing, where you're generating a lot of data. For example, that lathe may be generating a huge amount of data, and you want to be able to, and it doesn't make sense to be able to sending all that data, particularly it might be low value data. That lathe is just spinning around and business as usual, and there's really no point in sending that information up. So you just want to be able to process it, maybe aggregate that data, and then stream that data, or then send data maybe every 5 minutes up to the cloud. And the final area is local intelligence. And this where it makes a lot more sense to be able to put machine learning models onto local devices and have those run on local systems. So for example, you might have a camera that is monitoring a production control system. And that production control system, it would not make sense to send every photo up to the cloud and have it processed on the cloud. It would make much more sense to process those messages and those photos locally and then make a decision, hey, look, there's a problem with that packaging going on in that production system. Alrighty, so now we've got the data up into the cloud. The next thing I want to talk about is about the insights. So what we need to do is we need to be able to store that data. And we will likely want to partition that data, and often we want to use that metadata to say, split out all the things that are all the things that are monitoring the HVAC system or the lathe systems or things like that. So you want to use that metadata to go and partition out the data. Now, also, it often makes a lot of sense to split out the data by the type of usage. So, for example, if you've got data that you want to go and use for reporting, then you would normally go and put that into a warm path because it's more interactive. But that storage is often more expensive. For data like auditing or logging purposes, it makes much more sense to go and put those into cold path storage. It's much cheaper, and then maybe you might use that data for batch analytics, machine learning, and things like that. You invariably want to go and transform the data, so you maybe have to transform different schemas, for example, before you store the data. You also likely want to go and process that streams of data. Maybe you want to go and aggregate that data through the system. And maybe you're only interested in data. Maybe every 5 minutes of that data is useful for reporting purposes, for example. Or maybe you want to go and evaluate against a set of rules. So, hey, look, the temperature has gone above 40 degrees Celsius. I want to go and generate an alert. And of course, it's likely you want to be able to view that data as it's traveling through the system. Okay, so the next thing I want to talk about is actions. Now, once we've got this, now we've built these insights, invariably what we want to be able to do is integrate that into our business systems. So really derive that value of all that data that's through and really be able to help us make better business decisions, but also automate interactions with the devices. Like the lathe was a great example, or maybe you want to turn off the lights in the building when you know that there's nobody in the building after a certain time of day. We might also want to go and use that data for machine learning and generate models that you might deploy into the cloud, or you might go and deploy onto intelligent edge devices. Okay, so that pretty much covers the session. So as I said, there's an extended version of the session. In that session, we'll go into much more detail about making this much more concrete. So we're going to talk about the cloud gateway, which is IoT Hub. We're going to talk about data enrichment, approaches to data partitioning, stream processing with functions, stream analytics, Databricks, and storage options and things like that. So the resources for this session here, you'll find at this location. So aka.ms/IoT/20 and resources. Now what I've done is I've curated a set of resources that I felt were applicable to this session, so kind of data-centric resources. So do check out that. Those are resources that you'll find up on MS Learn and super useful. It's already been mentioned, but do check out the Microsoft certification. So AZ220. Go to aka.ms/IoT20/certification, and we also have a 30-day offer, which is to reduce price for certification. So do be sure to check out aka.ms/30 days to learn it IoT. And so thank you very much. So hopefully you got that, and hopefully that was, hopefully you understood more about it. And do check out the extended version. It's a 45-minute session, which goes into much more detail. Thank you.
Thank you, Dave. Such a great session. I'm always learning something new from you.
Thanks,
And,
Val. I'm not sure that's not true.
And as we know, the data collection by itself does not really provide the business value. The goal from IoT is from those insights and actions that the businesses can have after they analyze the data. So thank you so much. I hope the audience found it useful. We do have a few questions from the audience, which is thank you so much, everyone, for participating and posting your questions. So we have a question: how to push telemetry data from the IoT device onto the web Blazor assembly? Do I need to use Signal R service, or is it possible with the IoT SDK?
Oh, wow. Okay. That's a pretty cool question. So the way you would do that, thinking about this off the top of my head, so you'd have a device and you'd push that into IoT Hub. And so you want to be able to get this from Blazor. Now you can't, you would have to probably go and use HTTP requests. So the very simplest architecture, you would have a solution, the data going up into, I think I've got an idea. You'd have the data going up into IoT Hub. You'd store that data somewhere, and then you'd probably have to have something like an Azure function, an HTTP trigger. And then you could probably get at that from Blazor by calling that HTTP trigger and saying, hey, get me the latest data from the data store. I think that's probably, given the limitations of a Blazor application, I think you'd probably go down that route. Something along those anyway. But do feel free to reach out to me at @DGlover on Twitter if you want to ask more questions.
I think I would do quite similar. I think when we talk about IoT, I always sort of tell customers to leverage not just the IoT set of services to build their IoT architecture. A lot of people think that IoT only sort of covers your devices in the IoT hub, but make sure you leverage all of the other Azure services, like serverless services that we have, like they mentioned, Azure Functions and Logic Apps, which are great resources to help you, build out the rest of the Azure side block by block. So I think it's a really great answer. I also have seen you do a bit of work with Azure Sphere. I've seen on your GitHub and Twitter. Do you mind telling me what Azure Sphere is about? Where can I get it, or anything, any info for Azure Sphere?
Yeah, sure. Thanks, Valerie. So yes, this is something, IoT security, I have to say, is kind of one of my biggest passions, and I think it is the number one thing we need to be thinking about. So Azure Sphere is really kind of three things. It's a device, it's a service, and it's an operating system. That all can be deployed and all together provide what we call and support something called the 7 properties of highly secure devices. So we have certified microcontroller silicon with a hardware root of trust. We have an operating system there, a highly secure embedded operating system. Interesting enough, it's a Linux-based embedded operating system. And the beauty of that is that you can go and build your solutions on top of that solution, on top of that platform. So you think about the traditional approach to building IoT solutions. If you think about, if you're building embedded solutions nowadays, you've got to worry about the communication stack, you've got to worry about certificates, you've got to worry about storage, you've got to worry about expiring certificates, all those things that not only are you building your solution, but you're having to worry about everything around it, particularly the security. The beauty of Azure Sphere is that you're building on a secure platform that is secure by default. So you have to focus on your solution. You don't have to become an infinite IoT security expert, because that is being done by the platform. So then you just focus on your solution. We worry about security, we worry about updates, we make sure that if there seems to be a particular set of attack vectors that are going around the internet, we make sure the Azure Sphere platform is secured for you. So you've got confidence and your customers have got confidence. We all have. So that's kind of what I love about it. Fantastic platform for building applications. Love it. And security is the #1 goal behind it.
And can I buy a device or a developer kit that maybe I can trial out? Like, how can I get started with Azure Sphere?
Yeah, absolutely. That's a great question. Thanks, Val. Yeah, so the easiest place to go is just really online stores. And there are really 4 devices out there in the marketplace today. There are 2 devices from Seed Studio. There's what we call the original Azure Sphere reference design board. You'll often see that it's called the RDB. Seed Studio also have a mini Sphere. To kind of give you a price point, they're around about the $60 to $70, no, actually maybe from $50 to $70 US dollars. Avnet also have a couple of devices. You've got the Avnet version 1 Azure Sphere device, and you've got the version 2 Sphere device. And again, similar price points. I particularly like the boards because they've got built-in sensors. They've got built-in for temperature, humidity, and pressure. They've also got an accelerometer, so you can have fun, building step counters and things like that and stuff like that. But yeah, just go up into your kind of your regular IoT, typically web online stores, and you'll be able to find them there. Super easy to get a hold of.
Awesome, thank you. Well, everyone, please make sure you follow Dave Glover on his Twitter. I'm sure he posts a lot about links where to get started with Azure Sphere and links to maybe where you can purchase a developer kit. But thank you so much, Dave, for being part of this event today, and I really enjoyed your session.
Cool. Actually, I'm going to add one more plug. Sorry, Val. Up on MS Learn. So up on MS Learn, there are 2 learning modules that are written on Azure Sphere. So there's an Azure Sphere IoT Central module, Azure Sphere IoT Hub module, and you get on top of those, and you'll be up and running with Azure Sphere in no time.
Awesome. Thank you, Dave. Thank you so much. Before we jump into the next session, make sure you have a look at our 30 Days to Learn in IoT challenge, as well as all of the learning material will be posted on aka.ms/IoTLP/blog. And up next, we have Adding Intelligence, Unlocking New Insights with AI and Machine Learning. And I'm super excited to have Akuncha Malik, who is a data scientist at Telstra Purple, a Microsoft AI MVP, and international speaker. After studying financial maths in Ireland, she realized that she wants to work with people, not just the numbers. And at Purple, she's working with clients to help them solve problems, making more informed decisions with data. She's a firm believer in diversity and inclusion, like myself, and loves machine learning, and that is becoming more accessible to everyone. She is also a director of Women Who Code in Melbourne, which is amazing. Congratulations. And I'm super excited to have you here with us today. And over to you, Akuncha.
Perfect. Welcome, everyone. Thanks, Val, for that fabulous introduction. So yeah, we're here for the Adding Intelligence and Unlocking New Insights with AI and Machine Learning session. As Val said, my name is Akuncha, and I'm a data scientist in Melbourne. So with that, let's jump straight in. So our plan today is to go through what exactly is machine learning, how can we really make our IoT solutions smart in that sense. So what we're going to do is go through one big example from an end-to-end perspective, just so you can get an idea of how a real IoT solution will work in this great new age. So there's animals kind of everywhere at this stage, this day and age. Some of them are really, really cute, but some are super, super annoying, like the possums outside my window every night at 1 a.m. that likes to screech every single time. And similarly, in America, there are the raccoons, and the raccoons like going through people's trash and making a mess in general, and are just super loud, which nobody really likes in the middle of the night. I can attest to that. So with that in mind, we've got Mel, who is sick and tired of these raccoons going through her trash, and she's decided she's going to set up a trash defense system, where her plan essentially is she's going to set up a camera, which will identify whether or not there's a raccoon in her trash or in her backyard. And if there is, it'll set off a light, which will hopefully startle the raccoon into walking away before it makes a really big mess. That's a great idea that she's got. So she goes about and sets out to start picking up her products and stuff that she's going to need to create this. So she gets a Raspberry Pi as a computer to run all the calculations on, a camera, a lamp, and of course, a Microsoft Azure subscription. So this is great. She's now kind of got a plan. Now the problem itself is the fact that her plan involves the camera looking at an image essentially and needing to figure out whether or not there's a raccoon in it, which traditionally seems like a really, really hard problem to solve, but not with machine learning. It's quite straightforward with that. So what exactly is machine learning in that sense? In its kind of barest definition, machine learning essentially is the ability to learn without being explicitly programmed. And let's talk about it in kind of traditional programming sense. So back in the days, what you'd usually kind of have in here would be an algorithm and some data. You give it to your computer, and the computer basically figures out what the answer should be at the end of the day. In machine learning, this is essentially switched around, where your answers and the data are what you give the computer, and that will tell you what the best way to learn and what the best algorithm will be. So in machine learning, that algorithm essentially is then just called a model. So for our example, what we want to be able to see happening is for our model that's now been trained to identify raccoons in images, we use that model, get new data, which is going to be all the images coming in from our camera, to predict whether or not there's a raccoon in there at the end of the day. Hopefully, we'll be able to stop them from making such a mess in our backyard. So that's what our aim is. So with that, let's have a quick look at how we would go about setting up this specific function, this model that we want to have. So what we want to see is an image in which there's a very peaceful looking raccoon, and we want the model to tell me that, yep, there is a raccoon in that photo. And that's basically a classification model. So we're classifying yes or no whether there's a raccoon in here. How do we go about making this function work? How do we make this actually happen? There's kind of two main things that you need in this world of machine learning. So you need data. So you need a lot of images of raccoons in different ways and formats. So some of them with blonde hair looking really, really angry, and some just very happy. But a machine learning model basically needs to see all different variations of it to be able to get trained up on it. So this is the training environment. And the way it trains it is goes through and learns and looks at different images, and it's trained up using different machines. So you need two environments, you need data, and you need your machines to be able to make a model, which will hopefully then tell you that, hey, there's a raccoon in this image. But with it being 2021 and this new decade of unprecedented times, you never know, what if it's not just raccoons that are causing mayhem in the backyard at the end of the year? What if maybe next year unicorns are also actually awful animals, which I really hope is not the turn we take, but that might be the case, and they might be the ones that you need to identify in your model too. All that really requires is just a retraining of your model. All you do is just add images of unicorns into your training data set and just retrain it, which now the model can identify raccoons and unicorns at this stage. So that's great. We now know how we're going to build this model, the basic needs that it has, and how do we actually get it to work. Where are we going to do it? How does this actually work? This is great in theory, but where are we going to go about doing this? So this is where the Azure platform is actually super, super cool, because it kind of caters to almost every single skill level. You might be here having zero idea of how you would make a machine learning model. That's completely fine. Or you might be a data scientist who's created hundreds of them in your past. It caters to both of those needs. So they have things like the domain-specific pre-trained models. What these are basically out-of-the-box, ready-to-go models that you just connect up through your APIs, and they have about 40 of them. So these are run, managed, and kind of updated and trained and everything by Microsoft themselves. And they cater to things like vision, speech, language, and search. Essentially, you can connect this up into your application and make any application be able to look at images, identify them, chat through speech bots and chat bots, as well as being able to understand multiple different languages. There's a lot more you can do kind of out of the box, ready to go. But if you are a data scientist and you need a lot more custom and bespoke solutions, don't worry, all your favorite tools are here as well, ready to be used in really collaborative scenarios, such as Azure Machine Learning Studio, which allows for people to, in multiple different teams, to be able to access the same data. So all those products are still available to you. And as well, always with cloud, you've got really powerful infrastructure backing you up, such as CPUs and GPUs that can be scaled to whatever level you need them to be. And they're always going to be fast and reliable. So now that we know how and where we can host this, how do we actually go about it? What are the different ways? So I'll go through a few different examples of how you can create your model in Azure. So one of them is the computer vision. So this is one of those pre-trained models. You basically put an image in and it tells you what's in that image. It's amazing. It's just no work at all that you need to do here at all. So that, for example, in that photo, you can see there's a lot of different descriptions that the API returns. Things like there's a ground in this photo, there's an animal, and so on and so forth. But when you kind of go back and take a step back and you think about our problem, which is just raccoons in our backyard, I don't need my camera or my machine learning model identifying there's grass and there's a bin and all these other things that might be in my backyard. I just want to know, is there or is there not a raccoon? So a custom vision might be a better approach in our scenario, where basically either their computer vision, the custom vision API service is what I would use, put up all my data in here, which would be just all the images of raccoons and the unicorns I can find, train it on that. And it's a very guided service altogether in terms of it guides you through, please put your data in, this is what you want to do, you can label it here and everything. And it shows you how to deploy and actually extract them at the end of it as well. But then again, you may be a data scientist and have a really, really deep need to actually be able to control every part of it, and you might need to make it really custom. So Azure Machine Learning Studio also offers that, where you can control end-to-end your whole pipeline. You can manage everything through ML Ops, where you can control everything that's happening. And that flexibility then is completely within your reach of what control goes where. So all the different options are available to you, and all of them will actually invariably end up to this stage where you've now got a model that can identify a raccoon in an image. It's kind of what you want. It's like, yep, there's my image and there's a raccoon in it. So now that we've got that, we've got our model sorted, we need to make the model go to work, right? We need our backyard to be safe, away from these raccoons that are constantly coming in and out. So let's put it to work. So let's just, before we put it to work, let's remind ourselves of our scenario. What is our IoT solution here? So we've got data coming in, which is going to be from our camera, which is going to send images to our model, which will analyze these and say whether or not predict if there is or isn't a raccoon in this image. And then there should be a triggering an action, which is going to be from our alarm, which is our light in this scenario, to scare away our raccoon. So there's two main options around this that I'll go through in terms of how you can set this up in your backyard. You can do it in the cloud completely. So we've got IoT and ML in the cloud. We've got our edge device, which will be our Raspberry Pi. So what's going to happen is it'll take a camera. Every image from your camera will get sent up to the cloud. In the cloud, it'll run it through your model. The model will say, yep, hey, there's a raccoon in this image, which will send a trigger back to your device saying, hey, you should turn the light on, get rid of our raccoon. But as you can see, it's a very long drawn out process, especially when there's images coming in every single second from this camera stream. So what you really would need is a really reliable internet connection. And even then, it might take quite a long time for this to come back just because there's so many different bits that by the time you turn the light on, the raccoon's already made a mess of your backyard. So we need something that's a little bit more faster around this whole scenario. So what you could do is actually do all of these calculations and prediction bits on edge. So what'll happen is your Raspberry Pi will be able to have your deployed model on there, and the stream from your camera will just send images to the model, which sits on your device. It gets a prediction there, and it turns the light on or off depending on whether there's a raccoon there. So here, there's absolutely no need for it to go up to the cloud. You can still connect it up. You don't even need a running Wi-Fi signal at all. Every few days, you can connect it up Wi-Fi, send all the data up to the thing, and you can actually monitor the usage. Hey, how many times over the last week has there been raccoons that I've deterred from destroying my backyard? So all those monitoring devices actions can still be taken part of. It's just the fact that the latency basically disappears, that there's just no lag from sensing that there's a raccoon to actually having an action take place. So as I mentioned, there are pros and cons to both in the cloud and on the edge. In the cloud, you've got remote monitoring. You'll be able to actually connect up multiple different IoT devices to be able to compare them as you go. And as always, infinite compute and storage to be able to train these machine learning models and everything else you've got associated to that data. But then with the edge, that low latency comes into play, where it's really, really quick. All the pre-processing happens with all your data on premise. It doesn't really leave it. You can leave it completely offline. And with that comes the power of data protection. You can keep your data private, completely local if you don't want it going up to the cloud. So for us in our backyard, what is the most optimal way of solving this problem? What we might look at is a mixture of both of those scenarios. We'll build, test, and manage all of our AI and materials up in the cloud. So basically, that's going to be training everything up. Everything sits there. We've got all the power of Azure. And we'll run the model locally on our Raspberry Pi in our backyard, where there's no time lag involved at all. It can be completely non-Wi-Fi. So now that I've mentioned IoT Edge, which sounds really, really cool in terms of, hey, it's just going to sit in my backyard and it'll do everything for me without an internet connection. How is that all going to work? So let's have a quick look at how exactly things will work on the edge. So basically, you can deploy your cloud workloads right into the IoT device. It can be Linux or Windows. The runtime is free and open sourced. You'll have modules which contain different bits of it. They're Docker compatible. And as well as that, you can actually interact with it through your cloud interface altogether and actually manage it locally or remotely as well. So let's take a deeper dive into exactly how this will work on Edge. So you'll have 3 modules, which will be your camera, AI, and your alarm module. So all these will talk to different parts of your solution. So camera will talk to, obviously, the images coming in. AI will sort through those images, and the alarm will be the thing that triggers your light. All of these will sit in your container registry in Azure. Just stores them in one place. Everything can talk to your deployment manifest. So bear with me, this is kind of the most complicated part of it. So deployment manifest essentially just manages what these modules go to, where do they sit, and how they all communicate to each other. All of this then just sits in your IoT hub, which can deploy everything into your local devices in your backyard, in our Raspberry Pis. So if we zoom into our Raspberry Pi here, what's going to be happening in there is on the Azure IoT Edge runtime, there's two modules that come by default, the Edge Agent and the Edge Hub. Edge Agent basically manages all the deployments and stuff, make sure everything's running. The Edge Hub is what talks to the different modules individually in communication. So we'll have a camera module, which will take the images from our camera, send them to the AI. AI will say, hey, is there or is there not a raccoon in this image? Send that prediction down to the Edge Hub. Alarm module will read that prediction, which might say, yep, there's a raccoon, get rid of it, which turns the light on. And if the light does go on, it'll actually send a response back saying, hey, I've turned the light on, that was an incident, which those incidents can actually be then sent up to the Azure IoT Hub to be monitored for later use. So with that, we've now created an end-to-end solution of getting rid of these nasty raccoons to stop messing up our backyard and creating really big messes out there, so that Mel doesn't have to wake up to it in the middle of the night and then clean it up tomorrow. And so I hope that kind of made sense, and it gives you a really good idea of how do we implement intelligence into our IoT scenarios. There's loads of different options and variations you can put into this. It'd be really interesting to see what you actually get around to doing. So with that, there are a lot of the resources here that you can go out to figure out how you might make your own solution work with some intelligence. And I think all of these will be shared in the chat and the side at the same time. And also learning paths. So there is a learning path available for this module, which you can go along and actually code and create your own intelligence edge with Azure IoT Edge solutions. I really hope you kind of go into it. It's actually really cool the way they've actually labeled it out. It's really interactive. Let us know if you do it at the end of the day. And there is certification as well, AZ220. It's available for you. This is a part of it. Go have a look at it. Might be something you might be interested in. So with that, I'm going to say thank you for listening to me today. I hope you got something out of this session. And yeah, thank you.
Thank you, Akanksha. Such a great presentation. I really like the use of raccoon to explain concepts. Awesome, great work. And as you know, for many scenarios, the cloud is kind of the way to go to process the data and apply business logic because it has limitless scale. However, processing data in the cloud is not always the optimal way to go because some customers might have connectivity issues or legal issues, or maybe they need to respond in real time. So that's why the kind of concept of the edge comes in quite handy. So thank you so much for sharing and giving us in the audience the overview of running AI models on the edge. I just have a few questions personally myself. I do a fair bit of work with the IoT, but not so much with AI. Can you give me any hints, what I need to know to be able to train my own custom object detection model for the use with the Azure IoT Edge?
Honestly, I think there'd be days where I'd be like, oh my God, yes, let's set up a Python environment and do all these really complicated bits. But there is just absolutely no need to do any of that anymore at all. With all these pre-trained models, it just saves you the time, and also it's a lot cheaper because you're getting your own time back at that stage. So all it really needs I think I kind of went through a very quick example of the custom vision API. All you do is upload a few images that you have. You can literally get them on Google, upload those, and it'll talk you through, okay, this is what a raccoon is. You tell the machine that, and it learns from there, and it's ready to go at the end of it. So it's basically a few images, and you've almost got a working model ready to go. So not a lot is needed, and there's a lot more documentation and stuff around that. If you do need it, we can get out to those after, but yeah.
I think I've seen a demo the other day. Isn't it just like a portal called Custom Vision, and you come in, you just upload the images, do the tagging, and then just click train, and it all does the magic for you?
Exactly. Just kind of like, it's amazing to me. Whereas like if I show it to I showed it to my dad, I was like, look, this is cool. You can do your own machine learning. He's like, then why do you have a job? I'm like, well, no. I feel like you're going too far the other way, but it is very good in that sense of, I think it comes back to accessible AI. Everyone can access it, and it just makes it so much more usable for everyone.
Yeah, democratizing AI. And I've worked with a lot of, not a lot, but a fair number of data scientists that they're doing a lot of amazing work, and they just don't have those skills. And having like a quite friendly UI to be able to come in and upload, and then I think there's even a publish to export that as a module and then deploy it to Edge, really enables them to go with their work and work on the things that really make a difference rather than worrying about Python and SDKs and all of that.
Exactly.
You know, we have multiple different customers, and I'm sure audience as well on the call, on the stream, that have, you know, that they build their model, the AI model, and then they might maybe deploy it, I don't know, somewhere in the dark warehouse as an example, or where it's like a raining environment. Will their AI model perform in the same way based on different environments? Will that change? Do they have to maybe retrain the model for different environments? Just any insight on that?
I mean, I think it kind of goes back to that idea of like, yes, AI is super cool, everything's doable in AI, but there are limitations that will always exist. So yeah, I mean, if you have a kind of not the greatest camera, which can't really pick up much, there's only so far the machine can go. I think the classic example that I use to try and explain this is like, if you can't tell me what's in this image, a machine can't do any better than you can. That's the only, always kind of a quick litmus test of whether it's good or not. But in that sense, yes, exactly. Because you can connect all your data, like, yes, you can run all this on the edge, it'll store everything locally, but you can use that data then to retrain your models to get them better. It's like, if this is my usual data that I'm going to have to look at, get that to be trained up afterwards, which is available so easily on Azure and stuff, because everything connects up really, really well in that sense of collaboration, that retraining is quite straightforward. Might not be something you'd want to do at times because you just don't want to be able to do it. Might take up too much time, but that option does exist for depending on the scenario you're in. I love using that "it depends" example for everything.
It depends. Awesome. And is there like a limitation on the type of a model that I can run on the Azure IoT Edge?
No, once you have a model ready to go, there, the way you'll deploy them and stuff, it's ready to go on the device. It's all connected up in that sense. So not really, just once it works. Obviously, it's only got a limit of how heavy of a production is required in it. Your Raspberry Pi can only do, I think they come in like 4 GB RAMs and stuff like that. That is kind of the limitation of how big a workload can your Raspberry Pi handle or your IoT device. But other than that, once it's been deployed, the workload, whether it's in the cloud or anything, it's the same workload. It's just whether your device can handle it.
And do you have any maybe examples of devices that the customer can maybe start? You mentioned Raspberry Pi, but there's any other devices that you might potentially have worked with that you can recommend to our audience to get started with building their edge solutions?
Yeah, I think Raspberry Pi has kind of just become the brand name for all these IoT things, but because it's a brand name, it's constantly sold out. Like, I've been trying to get my hands on one for the last like 3 months now, I think. But the Arduino brand is another one that I have used. I can't think of any off the top of my head other than those two at the moment, but those are very handy, like especially around Australia. I don't know anything about anywhere else, but they're really easy to get your hands across, and they are also still fairly cheap, around the $30 mark, where you can get a really big kit to kind of get everything going. But I think it's one of those things. There's so many blogs, especially I know there's a lot of the Microsoft IoT people talking about all these things, that there's definitely enough resources for you to go. You'll find a link, no problem, about what is and isn't good very quickly.
Yeah, I agree. And do you have any specific, maybe you can give like an example of where you've seen in personal life, working with customers, application of IoT Edge or running the AI model on the edge? That could be maybe in retail or in healthcare. Would love to know from your experience, what was it for you?
I think, I mean, I won't mention any of the client ones, I think off the top of my head, just for the safety of like privacy and stuff. But I know in just internally, we did it as a showcase thing where, this kind of sounds a bit bizarre, but also it's a very techie answer of like, yeah, working in tech consulting, where we built out a Lego train just as a kind of a big showcase model, and we built a digital twin out of it, it was a really good day in the office where I was just building Lego, I won't lie. But we built out a bunch of different stations and had kind of how many people are on train at any given time. All of it was built out on an IoT scenario of, yep, it can sense how many people are there, what's the temperature and different little things, whether it's going to stop at this train, predictions in terms of how busy a train will be at a given time of day. So I don't think it necessarily answers your like real life explanation, but those kind of things are being used by public transports and different facilities across Australia, I think, at the moment.
Yeah, definitely. And I've worked with a lot of use cases potentially in retail, in-store analytics and things like that. So there's a lot of applications of running AI models on the edge in sort of real environments. So thank you so much for sharing that with us today and for your session. Thank you.
No, I'm glad. I hope someone goes out and actually tries this and lets us know at the end. That would be the icing on the cake.
Awesome. Thank you for your time. Well, before we jump
Perfect.
into the session, make sure you have a look at our 30 days to learning challenge at aka.ms/30 days to learn IoT, as well as all the learning material will be posted on the aka.ms/IoTLP/blog. So make sure you check that out. And up next, we have Big Data as your new operational data source. And I'm super excited to have Peter Myers with us today, who's a consultant, trainer, and a presenter from Melbourne, Australia. Welcome. And he's worked with Microsoft database and development products since 1997 and being an Azure data platform MVP since 2007. A lot of things you've been doing, so I'm super excited to have you here today. And over to you, Peter.
Well, thank you very much, Val. And I've got a bit of a treat, I think, the way that I'd like to launch into this segment. So I'm putting up here a Power BI dashboard. Can you see it, Val?
Yes, I can.
Okay, and I've designed this as a real-time dashboard, and you'll see that it can update in real time, and I've just submitted my survey results. And perhaps just for the next minute, I'd like to invite the viewers, if they'd like to use the QR code they see on the left, or the tiny URL across the top, a simple survey of 4 questions, and when you click submit, it's going to push results real-time into the dashboard, and this will be so relevant for what I'd like to be sharing with you later in my presentation. So perhaps while these results are coming in, Val, we can have a bit of a chat and maybe encourage people to submit their survey results.
Awesome. Let me just bring my phone up so I can do that as well.
The real-time capabilities in Power BI are one of my passion points, so to speak, and it's to me it's just a really exciting way to bring your data alive, and so I've had a number of customers that have really benefited from a number of different scenarios you have with Power BI real time. So we'll get some feedback. It also lets me understand who the viewer audience is. And I can see, we've got a couple from Australia. We've got one person coming in from the United States. And I want you to think about your own data here and how real-time scenarios might play out with your own data. And I'll be sharing with you a link where me and Miguel Martinez from the Power BI desktop team, we put together a very comprehensive video that goes through all the Power BI stories. So there's only so much I can talk about in this segment, but if you want more info, I'll give you some links shortly. Awesome. So as those results are coming in, we can take a look at the role and we can see we've got, 5 IoT engineers, 3 software developers, a couple of IT managers. From a point of view of what's most important for the audience, it's Azure IoT Hub and real-time Power BI. Awesome. We'll definitely be talking about those shortly. And then from a point of view of Power BI experience, this just gives me a gauge for perhaps where you're at. And so while the results are still coming in, what I'll do is come to the dashboard and just come back here and ask a question in natural language. For example, what is the average Power BI experience? And we can see that based on the results coming in, 3.5, I'm going to pin that back to my dashboard. So now we can see that we've got an extra metric to monitor here about what the self-rating is for Power BI. Awesome. Thanks very much for participating in that survey. I think it's probably a good time to launch into the presentation. All right, so welcome, Big Data 2.0, IoT as your new operational data source. All right, so my name is Peter Myers, and I'm a BI expert, I think as Val mentioned, with over 20 years experience working with Microsoft Data Platform, and I'm also a most valued professional since 2007. Okay, then, well, let's make a start. For a few years now, Big data and IoT are almost mainstream topics. And if we look at the actual deployments, we often see that IoT data stays in its silo. mainly benefiting the service or part of the organization that deployed it. But what happens when a CEO comes along and she says to you, I want all that IoT data right within my sales dashboard? Well, if you're a data engineer or an IoT engineer, then it's your call to make it happen. So in this presentation, I'll explain why it's important to integrate IoT generated data into your data landscape, and I'll provide you with an overview of the strategies and benefits of doing so. All right, so I'll start by quickly introducing the challenges of big data and the kind of data IoT systems produce. Then I'll talk about the challenges of ingesting and storing IoT data and why it can fit within your existing data estate. You'll then better understand why using IoT as an operational data source for your analytical system can unlock insights and actions across your organization. To achieve this goal, you'll probably need to work as a team together with data and IoT engineers. And so this presentation is mainly targeting these two roles. Well, okay then, let's start with a quick primer on big data analytics and data management. Generally speaking, big data refers to a system that produces such a diverse quantity of data that traditional BI systems can't analyze it. And we define big data systems with three adjectives called the three Vs. And you're probably familiar with them, but perhaps there's some that are not. So let's begin with the first and most obvious, being volume. And it's simply the amount of data stored to be analyzed. And then there's variety. It's the changing and unstructured nature of the data that you're analyzing, as opposed to relational data where all the data is well organized in tabular format. Big data systems can analyze semi-structured data like JSON documents or unstructured data like image and video files. And then lastly, there's velocity, which is the frequency that your system generates data. And in the IoT space, it can be as slow as a metric per hour or up to several metrics per second. Now, these three adjectives can seem a bit abstract, so I'll now talk about what is probably the biggest big data project in the universe, and it's the Square Kilometre Array Radio Telescope. Now, it's an ongoing international project of radio telescopes based in South Africa and Australia, and it will be the most sensitive radio instrument in the world. This project is also probably going to be the paramount of big data projects. This mesh of radio telescopes will provide scientists with 50 terabytes of data to analyze every day. And this data will be in the form of images and signals and with a lot of metadata associated with it. However, there's a lot more behind it. The actual sensor data generated by the telescope is expected to be 7,000 teraoctets every second. And all in, they should expect to store 600 petabytes of data every year. Now, okay, you'll probably not have to deal with this type of volume of data, but nonetheless, the big data principles will apply. The Square Kilometre Array Radio Telescope project is a great example of the three Vs of volume, variety, and velocity in a more concrete example. Now, let's have a look at the variety of data IoT systems can generate. First, there's the telemetry data. It comprises mainly JSON documents, even if from time to time we encounter a lot of other formats, including column encoded. Then, there's all the metadata associated with the data itself, the IoT device or the system. These metadata can be precious sources of information for your analytics, and they can also be enriched in the process with reference data or other sources. The diversity of IoT-generated data can be immense. Consider images and video streams, but also other formats. IoT gateways like Azure IoT Hub facilitate file upload from IoT devices, enabling the collection of all kinds of unstructured data. Getting insights from this kind of data reveals some challenges. You see, IoT data lacks structural consistency. With your IoT deployment, you might have 10 different types of data, each measuring temperature, yet all of them using different type and structure of data for reporting this one measurement. These different types can make it extremely difficult to aggregate and compare results. So to analyze sensor and asset data accurately, you'll need the context of where the data came from, the asset's relationship to other sensors, and access to historical performance. IoT data needs to be analyzed and consumed alongside other business data to show the true business impact of IoT initiatives. With a complete IoT deployment, you could have hundreds or even thousands of devices that are emitting large volumes of data. To unlock some insights, especially if you want to apply machine learning, you would need an almost infinite retention. And this, of course, would require an unrealistic amount of storage. If you consider then the characteristics of IoT data, you'll probably see it's well aligned with big data. To solve the big data challenges, data engineers and IoT engineers need to work together and understand each other. So the remainder of my presentation then, and the supplemental extended version that I'll provide you with a link, aims to create a bridge between these two roles. You've now seen why IoT and big data share the same challenges about the type of data they handle. You'll now see why integrating IoT data as your new operational data source can be facilitated with Azure solutions. First, we need to see from where the IoT data comes from. When designing an IoT solution, you'll probably get all your devices connected to a central hub called an IoT gateway. From there, you can have the applications, storage, and databases listening to incoming messages from your devices. Now, Azure IoT Hub is a managed cloud gateway in Azure. And you can learn more about Azure IoT Hub at aka.ms/IoT10/watch. Now, you can then reroute your messages to several destinations. IoT Hub in Azure offers out-of-the-box support for several storage systems, including storage accounts, data lake, and time series insights. You can also route messages to custom-made applications through Service Bus, Event Hubs, or any AMPQ or Kafka Open Protocol client. You could also leverage processing services like Azure Stream Analytics or Azure Functions, which allow you to process, enrich, and store your IoT data pretty much anywhere you want. Now that you've seen where IoT data comes from, let's see where you can land it. The first option is into relational databases. Now, in this case, you won't want to send all your data, otherwise you'll quickly overwhelm the database. Instead, you will likely send aggregated data with specific conditions. If you have a data warehouse solution, you can also output aggregated data to it and leverage your existing BI capabilities. NoSQL databases like Graph or time series databases can be an interesting alternative. For example, you could create a graph representing your sensors, your rooms, buildings, and facilities. And by doing so, you could simply query aggregated data at the room or building level. And at least if you have a data lake, you can send all of the IoT data into it for later analysis. Now, of course, Azure supports a range of services covering all these types of data stores, from the classical Azure SQL database to a managed Hadoop cluster with HD Insight. Some Azure services are a great match for IoT data. You can also leverage open source data stores hosted on Azure, like Azure PostgreSQL or the MongoDB driver in Cosmos DB or elsewhere. If you're looking to model the physical world with interactions, I encourage you to check out the Azure Digital Twin service. It enables the creation of knowledge graphs based on digital models of entire environments. So whatever the data stores are within your organization, whether just an operational database, a traditional data warehouse, or a big data infrastructure, the point is you can land your IoT data in it. If you want to see how you can export your IoT data to a data lake and to an existing data warehouse, I invite you to watch the online version of this talk available at the URL I mentioned just earlier. All right, so you've seen that there are different data store options you can use to store your IoT data. But is there a data store that really shines with IoT data? Well, actually, there are two. The first one is Time Series Insights. You've already seen that Time Series Insights can ingest IoT data easily. And you can also create time series hierarchies allowing the execution of a query to retrieve the average temperature, for example, of the building that I mentioned earlier. You can also easily retrieve this aggregated result from Time Series Insights. As the volume of IoT data is likely to be large, you may be thinking that the second preferred destination would be the data lake. However, a lot of organizations today aren't yet ready to tap into this type of data store to deliver insights to their operational dashboards. Instead, they tend to favor the existing data warehouse infrastructure, which provides data ready for analysis together with great security features. With Azure Synapse Analytics, today Microsoft are bringing to you the best of these two worlds. Azure Synapse Analytics can query unstructured data stored in your data lake while maintaining a classic table structure that you'll find in any relational data warehouse. Thanks to its distributed architecture, you can tap into huge volumes of data in seconds. So you just saw that integrating IoT data into your data analytics landscape is possible. Now, let me show you some concrete examples on how to surface insights and actions from your IoT data. So one of the most straightforward ways you can surface your IoT data is by augmenting an existing dashboard with it. So here in this example, you can see a Power BI report authored by the IT department of Contoso. It comprises various visuals relevant to monitoring public school data. Now, notice at the bottom of the report, there's air quality results. So here we see, side by side with data sourced from operational databases, data that's sourced from an air quality IoT deployment. Let me now describe to you how this report was created. Existing data comes from operational databases and a Power Apps application. The IoT data comes from two different data sources. Air quality alerts are stored in an Azure SQL database where the data was output from Azure Stream Analytics jobs. These jobs only output rows of data when one of the sensor values rises above a pre-configured threshold value. And hopefully, our SQL database table will contain very few rows. The chart at the bottom right is a little different. It's a graph of the sensor readings from an interval of 5 minutes. For this chart, all the processing is done in time series insights. If you'd like to see a complete demo of using IoT data in Power BI and exploring historical data with Azure Synapse Analytics, please watch the online video of this presentation that's available at the URL mentioned earlier, and I will mention again at the end. All right then, so data engineers are mostly asked to work on historical data. And with Power BI and Azure, they can also easily work on real-time analytics. By using Azure Stream Analytics, you can process, aggregate, and filter data coming from IoT hubs in real time and output this data to various destinations. For example, you can use the streaming data tile within a Power BI dashboard to display results in real time. Not different to what we just saw in demo. And no code is required in certain situations. You just need to write a SQL query. But why limit yourself to crunching and displaying data? When you know how to use Azure Stream Analytics, you're one step away from executing your code, or even better, a workflow. Here, the same Azure Stream Analytics job is used to launch an Azure Logic app, a no-code serverless workflow service in Azure, allowing you to create or execute actions in a wide range of applications, like sending a message to a specific Microsoft Teams channel. Sending real-time alerts to Microsoft Teams and creating a real-time Power BI dashboard are just two of many demos in the online version of the presentation. Again, available at the URL mentioned earlier and that I'll mention again towards the end. Well, here's that URL again. You can watch the online version of this presentation at aka.ms/IoT40/watch. It's a demo-heavy presentation showing you how it's all done. You can also find all the presentation resources in the IoT Learning Path GitHub repo at aka.ms/IoT40. If you're interested in monitoring your data in real time with Power BI, and why wouldn't you be, I encourage you to watch the latest resource that is available at aka.ms/RT webinar. It's a 60-minute webinar presentation delivered by myself and Miguel Martinez, a Power BI product manager. And so together, we put this webinar together to show all the possible how-tos, including Azure Stream Analytics, even using PowerShell scripts to generate real-time results through dashboards. And best of all, it covers the newest Power BI real-time capability known as automatic page refresh, which is also a consideration with your IoT data. If you landed in Synapse, you could produce a direct query model over Synapse, and then you could use the new automatic page refresh in Power BI to deliver real-time results, if appropriate, across that data. Now, if you prefer to learn by doing, I recommend you check out the great collection of Microsoft Learn modules. Be aware that Microsoft Learn is a free online learning platform where you can complete interactive learning experiences. Let me now finish by crediting this fantastic open source image that helped me deliver this presentation, thanks to Donald Giannotti. And finally, thank you, viewer, for attending this presentation, and I hope that you found the content to be informative and relevant.
Thank you, Peter. Such a great session. And I think, as I've mentioned before, kind of the goal and the value that IoT provides is from the data and the insights and actions the customer can generate. So thank you so much for giving the overview of all of the various analytics services like time series insights, stream analytics, and Power BI. We have many customers that have multiple thousands, and in IoT terms, billions of different devices that are sending through the data. Are there any limitations on how much data can be stored in, let's say, Power BI for visualization as an example?
So storage is always going to be a good discussion, and we can always say there is infinite store value, because a data lake, if you absolutely must store everything, then Azure Data Lake you can think of it as the bottomless lake. That sounds a bit austere, but when it comes to Power BI, okay, and this is my strength, by the way, talking about how you can deliver your data no matter what shape or form or velocity that data is coming in at. It's all a question of the data modeling in Power BI. So I would encourage people, if they have that question, to actually dig deeper. And the real-time webinar that Miguel and I put together will answer those questions. But to answer the question right now, the dashboard that we started with was actually using a web app that was just programming and using the Power BI REST API to push data into what's known as a data set. But I could have used Azure Stream Analytics also to push into that same data set. So at the end of the day, what you might see is that Azure Stream Analytics actually has jobs that output to multiple places, to your data lake, to Azure SQL, but it could also, for the real-time dashboard, it could push direct to a data set in Power BI. And therefore, there's really little concern about storage. Like we have what's called on a push data set that is designed for real-time delivery. There's an option to work with what's known as the basic FIFO mode. Now, ordinarily, a table in that data set cannot exceed 5 million rows. But if you switch the design of that data set to basic FIFO, then it will keep a rolling 200,000 rows. And often for real-time dashboards, we're really looking at the latest data. We're not so much concerned about the history, although that's relevant for other analytics tasks, and we can use the warehouse to support that. But for the real-time story, what I do see is that Azure Stream Analytics is just pushing to multiple outputs, one of which is one of those basic FIFO data sets in Power BI.
Is there a way, so I know, let's say we have IoT Hub, and then you can push the data into other services and then push that into, let's say, Power BI. Is there any way maybe I can filter the data, let's say certain alerts or anything like that? Maybe I can filter before the data even lands in the IoT Hub, or do some filtering before the data lands in Power BI as an example, to sort of kind of clean up the data or transform it?
So I think you can filter at multiple layers, but I guess you need to ask the question, do I need to permanently store everything? In which case, you're going to land everything in the lake. And then your considerations are, and remember, the focus of this session is really about the analytics. We've got these questions that need to be answered, and some of those questions are pressing and need to be answered quickly on the latest data. And so, Stream Analytics in a job, with the query that drives a job just being very similar in dialect to a SQL statement, you have a where clause, so you can use that. The other thing is that Power BI itself, you can publish alerts on dashboards, and those alerts can notify you, right? And the cool thing about that is that there's a native app file for Power BI, which is the Apple Watch. So I do have some of my customers that receive pop-up alerts on their watch when certain thresholds are crossed on dashboard tiles that are based on real-time data. Okay, so I guess to the point of your question is you can filter at whatever layer makes sense and that is logical for your application design.
It is nice how it integrates, with different push alerts. You can plug in Logic apps and various other Azure services to kind of do alerting and processing. So it's really nice how all the components and all the blocks really nicely work with one another to create that end-to-end IoT solution. But
you know what it reminds me of, Mel? It's like, as a kid, I grew up with like Lego and blocks and just putting them together to create the solution I needed. And when you look at all of the blocks that we have today in Azure and Power Platform, it's just that fun game coming back again, where you just choose the right blocks that make sense to build up that solution that that your boss or your manager needs.
That's how I usually introduce Azure to my customers. Like, have you played with Lego? It's a similar thing.
But it's more fun, right, Mel?
Awesome. Well, thank you, Peter, so much for your time today. I've learned a lot, and I'm sure audience has enjoyed it. So thank you so much for being part of this.
You're very welcome. Thanks for having me on.
And before we jump into the next session, make sure you have a look at our 30 days learning challenge at aka.ms/30 days to learn at IoT. And all the learning material and the sessions recordings will be on the aka.ms/IoTLP/blog. So up next, we have Get It to Solutioning, strategy and best practices with mapping designs from edge to cloud. And I'm super excited to have Has Altair with us here today. Who is a developer at heart and a consultant by trade, who works as an executive director at VNext Solutions and based in Melbourne, Australia. He specializes in data, IoT, and AI, and we're super excited to have him here today. He's also a Microsoft Azure MVP and a regular organizer and speaker at local and international conferences. I'm super excited for your session, Has, and I'm really happy to have you here today. So over to you.
Hi, thanks. Thanks, Belle. Hi, everyone. Thanks for joining us. In this session, we talk about getting into solutioning, where we cover strategy and best practices when mapping designs from edge to the cloud. My name is Has Altair. I'm director at VNext Solutions. We are a consultancy based in Melbourne, Australia. I've been working in this space for the last 4 or 5 years. I've done a number of IoT projects. My last IoT project won IoT Project of the Year here in Australia. So I'm quite passionate about this field, and I hope that you will find the next few minutes useful. So I would hope that you will take 3 things from this session today. The first thing is we'll look at some strategies of how you can secure IoT device connectivity in the real world when it comes into edge environments. And then next, we will look at common IoT solutions architecture and how can they be adapted to a variety of business verticals. And then lastly, we'll look at some techniques for implementing AI solutions on the edge to support intelligent video analytics in real world environments. Before we go any further, I would like to address the elephant in the room, and that's being security in IoT. Needless to say, it's critical to have secure platforms, but I'm sure you have seen a number of breaches that happened in IoT solutions. So why is it so hard to secure IoT solutions? One of the reasons is that we are relying on small devices, constraints, and sensors that are running in the wild. Another reason is that part of, in an IoT solution, part of your solution would be accessible from the public internet, which makes it quite hard. Here are some of the recent examples that we have seen high-profile security breaches for IoT solutions. So the first one, the Mirai botnet attack from 2016, where hackers basically penetrated or compromised hundreds of thousands of IoT devices, and they use those to do distributed denial of service attack. Basically, they're under the east coast of the US offline for a good part of a day. Another example is a data breach that happened recently in a casino in Las Vegas, where attackers basically use a vulnerability in the thermometer in a fish tank, and then they use that to access the network of the casino, and then from there they gained access to the high roller database. And the third example that I have here for you is the Triton malware attack, where basically attackers managed to manipulate the different layers of the emergency shutdown in a critical infrastructure. We're talking about nuclear, oil, and gas plants, and then they managed to keep the plants running while they are trying to gain access in the background. Thankfully, in this scenario, the attackers accidentally triggered the emergency shutdown, and then they were noticed. So they didn't manage to create a great deal of damage. But the reason why I'm showing you these scenarios is to tell you that security in IoT is really critical, and we really need to take that in all of the layers that we look at in the IoT solution. So how does Azure look at security? Well, in Azure, in Microsoft Azure, we look at security end to end. So we start with securing the devices, and we have a number of levers that we can do there, starting with the device identity. And you have different ways of managing the attestation of the device using certificates, symmetric keys, as well as secure hardware modules. And then you have the ability to manage device management as well as authorization. And then obviously it doesn't stop at the device, so we need to secure the communications, and we use TLS-based handshake and encryption to secure the connection channels. And then when it comes into the cloud, obviously Azure gives us a number of services that allows us to secure our environment in Azure, starting with Azure Security Center and Azure Active Directory, Key Vaults, and the likes. Now, whether your devices are connecting via an IoT Edge gateway, or whether they are connecting using the SDK, or even if they are microcontroller based, you could use Azure Sphere to secure these devices and start sending all this telemetry data into Azure. Azure not only does all this monitoring on top of this data, but it does a lot of the intelligent threat detection, and then it would provide you with recommendation on top of that. This not only allows us to secure the IoT solution, but also secures the whole end-to-end solution using things like the Azure Security Center. And then you could build on top of that. You could build notifications, automations, and things like that. It's worth calling out, if you are using an Azure, if you are using a microcontroller, you would want to look at Azure Sphere, because it's really, you could think of it as managed security. So it gives you a platform with managed services and the characteristics of a highly secure environment, and then you could build on top of it rather than you having to start from scratch. And then within Azure, you have 60+ Azure regions around the world, which would allow you not only to get low latency and high throughput, but also it allows us to build multi-region failover. If there is something that happens, you don't want your whole system to shut down. You want to build a seamless and an easy failover from one region into another. And Azure gives us the ability to do that. Obviously, Microsoft invests a lot in security. Greater than $1 billion every year is spent in investments on security from Microsoft. And if you are building a solution for highly regulated environments, such as medical or finance, you could take advantage of the 93+ compliance offerings that are available in Azure. So we touched a bit about security. Let's look at the edge. What are some of the common patterns that are common when it comes into connecting devices to the edge environment as a gateway? Well, there are 3 common patterns. The first one is being the transparent pattern, where basically you have IoT devices that are capable of connecting directly into the cloud, in which case the IoT Edge runtime will basically just pass through. So the device will connect directly into the IoT Edge environment. Their identity will be stored in the IoT Edge, in the IoT Hub, and then the IoT runtime will basically just pass through those connections. The second pattern that we see quite often is protocol translation, where you might have, say, a number of devices that are highly constrained, or they are not able to connect directly to the cloud. So they might be connecting using Bluetooth, Modbus, or things like that. Or you might even have implemented your own proprietary protocol. In this case, the device will connect to the IoT Edge Hub, the IoT Edge runtime, and then the IoT Edge runtime will basically manage all the communications with the IoT Hub. The IoT runtime, the IoT Edge runtime, will basically act as the translator of those protocols into the IoT Hub, and then manages all the sending and receiving of the data with the IoT Hub. Now, the third scenario, or the third pattern that we see quite often, where you might have these constrained devices or legacy protocols that you might be using, but then you want to manage their identities in the IoT Hub, in which scenario you will go into the third pattern, which is the identity translation, whereby the device will, the IoT Edge runtime will impersonate each of these devices when it's connecting into the IoT Edge, into the IoT Hub, sorry. So now we have covered security. Let's start looking at some of the greater concepts when it comes into the IoT reference architecture. Now, as we have seen in previous sessions, the innovation in the field of IoT happens in waves. So we got the first wave of the dominance of cloud platforms, where we got unlimited resources that allowed us to power a lot of the innovation that runs the IoT projects and solutions that we have seen quite common now. And then as our devices have become more and more powerful, we started shifting some of this computation and processing of the data down to the edge, which allows us to now not only process data, but be quite intelligent and run IoT and machine learning algorithms on the edge. And then the third waves, or the next wave that's going to be in this space, is basically the digital twin, which would allow us to take advantage of both, not only create intelligent algorithms, but also create virtual replicas of the whole physical world, whether that is vehicles or buildings or things like that, and then run intelligent algorithms on top of it. It allows us to create modeling, not just seeing the historical data, but create modeling to predict different scenarios of what we have today and see what would be an optimal scenario. So we looked at some of that, the concept of IoT and IoT Edge. How relevant is IoT to your own domain? IoT is really relevant to all lines of business, regardless of which sector or industry you are in. Whether you are building software to detect and prevent outbreaks in people going back to work, whether you are working in medical settings and you're trying to do real-time patient monitoring, whether you are working in fleet management and you're trying to develop smart vehicles and smart cars, whether you are working in manufacturing and you are trying to reduce downtime and waste by using anomaly detection. I've been lucky enough to work in the smart cities and smart meters field. I've been working with a number of utility companies here in Victoria. And it's really good to see the innovation there, where we are making the world more sustainable and managing resources better. And lastly, the potential of IoT in retail is quite immense, because we can augment the experience of the customer and create real-time demand and inventory management, which would allow us to be more optimal in terms of how much we are stocking and our back ordering. But it's not really just these scenarios, it's really a lot more. Regardless of what field of business you are in, IoT would be relevant to you. So when it comes into the reference architecture, there are really three key elements that are critical for any IoT architecture, regardless of the business, regardless of the specifics of the IoT solution. There are really three key things. First, we have the things or the devices. That's where we are observing, collecting, and measuring the data. And then the second part is, once we have this data, we use this data to generate an insight. Once we have that insight, we use that insight to trigger an action. So really three things. You have the things or the devices, you have the insight, and then you have the action. And Azure provides us with a range of really great services that allows us to build good architectures on top of that. We could even extend this a little bit further and trying to create a common concept out of that, where we could look at, regardless of how your devices are connecting to the cloud, they would basically connect to the gateway, which is the IoT hub. And then from the IoT hub, we could build queries and intelligent analytics on top of the data as it's coming in flight using stream analytics. And beside that, we could run data integration that is using time-critical or needing time-critical data using the warm path. And then we could use cheap storage to store data using the cold path, and then use machine learning models to use this data for training models and then pushing back into the edge. And we'll see a scenario of that shortly. So now that we have looked at some of the theory and the concept, let's look at an example of using AI on the edge to support intelligent algorithms, intelligent video analytics on the edge. Now, in the next extended session of this one, we'll look at a complete end-to-end solution of using IoT AI on the edge. We'll start by setting up the device. It's actually an NVIDIA-built device, and then we'll start ingesting video streams from multiple sources, and then we'll create machine learning models with custom built models to do object detections, and then we'll use Azure Stream Analytics to query and set up the query, and then push that into the edge environment. Now, once the machine learning models are running on the edge, we'll use the summarized data. Once an object is detected on the edge, we'll use that summarized data to send it into Power BI as well as time series insight. Now, because the solution is built on Azure, you can see that it naturally aligns to the Azure IoT reference architecture. As we have seen before, we are using the Azure IoT Hub, and we are using the Stream Analytics as well as the warm path. Now, one thing to note here is that we are using the cognitive services to do that object detection. But as we start gathering more and more data, and we are using the cold path to store this data, we will retrain this model, and then we will push it again. So we have closed loop, as you can see, this big arrow that's going here. So we'll train the model, and then we'll push it again into the edge. So the accuracy of our model is improving with time as we gather more and more data. Now, you might have seen in the media one of the high-profile projects that's built on top of the demo that we are showing you today is Project 15, where Microsoft is using intelligent video analytics to accelerate conservation and improve sustainability. This is one reason that I really like IoT, because I think it can help us in creating a sustainable world. It's not just the cool technology that we need the technology to improve our world, and that's what IoT enables us to do. So Project 15 was built on top of the similar reference architecture and the demo that we are seeing, using modified object detection model, as well as some updated business integration. The reason why we are telling you this, because you could really take the demo and the instructions and the solution artifacts that we have here, and then you could modify it and create whatever solutions that you could come up with. The opportunities are quite immense. So it would be really exciting to see what you can build. If you would like to develop a little further and learn more, I would strongly recommend the Getting into Solutioning module on Microsoft Learn, and you have the link there where you have a number of tutorials that are bite-sized, quite small, but it allows you to go more in depth. And if you want to learn more, I would strongly recommend that you do the Azure IoT Developer certificate. Not only it allows you to stand out from the competition, but it also helps you gain broader perspective, not just the device or the cloud, but end to end. So thanks for joining me today. Here are a few links to help you learn further. My name is Haz Altaya, and it's been a pleasure to sharing these few minutes with you.
Great session. Thank you, Haz, so much for your time and for giving various strategies for securing IoT devices in real world for edge environments. Once again, I've learned heaps, and I do have a few questions. So do you have any suggestions for customers or even folks that are only starting with IoT around how to securely onboard IoT devices at scale?
Yes, Azure actually has a really great service that's device provisioning service, where it allows us to manage devices at scale. So when I'm working with utility companies, we're talking about hundreds of thousands of digital meters, or sometimes even millions of these meters. You can't really provision each of these devices. So there are two services in Azure that really can allow us to do that. One is device provisioning service, which allows us to provision the devices seamlessly when they go into the field. As they activate it, they get provisioned into the right environment. And then the second service that we could use is basically plug and play, where basically you could think of it just like you do when you purchase a mouse or a keyboard for your machine. You don't have to install an adapter or anything. You just plug it and it would just work. So it's really great I think it would allow us to take IoT even more mainstream and get more adoption.
Mm-hmm. So, like, my background, I did electrical engineering back at university, so I played with a lot of different microcontrollers and Arduino boards. Is there anything from Microsoft that would help me secure like a microcontroller-based board?
Yeah, definitely. One of my best services is Azure Sphere. And like Dave was saying in the previous sessions, Azure Sphere is a really good ecosystem to allows us to secure a solution and build on top of, rather than us having to reinvent the wheel and try to take full ownership of the security of the platforms. We could walk on top of, or we could rise on the shoulders of a giants like Microsoft, where Microsoft invested in creating a managed security platform basically for Azure Sphere, and then we can build on top of it. One of the key challenges in securing microcontrollers, because they are very constrained device, so even if you manage to secure it, if in the future there was a security breach, it's very hard to push an update for them. And that's why Azure Sphere is really creative and innovative, because Microsoft is managing that for you. So you don't really have to go into the nth degree of securing that. Microsoft has already done the hard work of securing that, and then you could build on top of it.
And just kind of building on the work with, my work with like microcontrollers, I know that some of them have like native MQTT protocols that they can only communicate with those protocols with other services. What sort of protocols does Azure IoT set of services support, and what kind of devices can connect to Azure?
Azure IoT Hub, actually, which is the gateway in your solutions in Azure, support a number of protocols. So it supports AMQP, MQTT, HTTP, HTTPS. But even if you have protocols that are outside of that, like I was showing before, we could use an IoT Edge as a gateway, and then we could use that as a protocol translation. So if you are using a Modbus, for example, or if you are using your own proprietary protocols, we could have a gateway in the middle, and then that would translate from your own protocol into something that's supported by Azure.
Interesting. So that could be kind of a use case for using, let's say, using Azure IoT Edge versus directly IoT Hub. Are there any other use cases where I would choose Edge versus just sending the data to cloud straight away?
Yeah, definitely. One of the solutions that I worked on, the solution that I mentioned earlier, that won Australian IoT Project of the Year last year, was a solution where we use IoT Edge in a mining field, 2 kilometers underground. So in these mining scenarios, we want to have low latency, high throughput. We can't rely always on internet connection. We're talking about 2 kilometers underground, so there is no internet connection. So what we did, we trained these machine learning models and we pushed them into the IoT Edge underground, and then we are able to do that anomaly detection and that intelligence algorithms on the edge there and then. We don't really have to send everything into the cloud. And then when some of these equipments come and above the ground, then we will do any upgrades or push new models into the edge.
Awesome. Well, I think as a takeaway for me is definitely get myself an Azure Sphere to play around with kind of security for the microcontroller-based boards. And I think after the session, I will go and try and build my own AI model using the custom vision and try and deploy it to one of my Raspberry Pis. But thank you so much for your session. And thank you so much for being part of this event today, Has.
Thanks for having me. It's been a pleasure.
Awesome. Well, what an amazing day today here, everyone. Thank you, everyone, for tuning in from all around the world. I've learned myself personally heaps. And as I mentioned before, if you want to get into IoT, check out the 30-day to learn it challenge, as well as all of the material and content and videos will be posted on aka.ms/IoTLP/blog. So if you want to check it out, please go to that link.
Hey, Val. Hey, look, I'd like to thank everybody for speaking and giving up their time today. It's been really appreciated. So Val, Jason, Akansha, Peter, and Haz, really appreciate your time. I learned a stack. I think I described it as drinking from the fire hose. There is so much going on. And it's just wonderful. For me, kind of one of the key takeaways behind this is really fascinating to see how we've been talking about IoT for quite some time, but it's this whole bringing together of IoT, data, machine learning, and that kind of whole virtuous cycle, how we can really make a real difference to the kind of the ways in which we operate in our cities, our businesses, and our personal lives, health, etc., and things like that. Hey, so Val, one of the questions I want to ask you, and I know you did touch on it before, is can you tell us a bit about what you do?
Awesome. All right, cool. Well, a little bit about me. I know everyone had an opportunity to intro, so I'll do quick one for myself. Originally an electronics engineer, and I did a lot of microcontroller-based boards and soldering for 4 years back at uni. And now I'm part of the Azure business group at Microsoft, leading IoT strategy that is working with partners, folks internally like yourself, and others, as well as customers, on landing on the same IoT strategy to get our customers to get the best value locally in Australia from IoT. Have a lot of passion for electronics, so I'm actually surrounded by boards, and I had to clean up my space a little bit for this event, but that's a little bit about me.
That's fantastic. I remember the time you told me that you'd done electronic engineering at university, and I think I was just jealous. For some obscure reason, I did business studies. I have no idea why. Hey, look, the thing I would really kind of emphasize behind this is you can see out of those 5 sessions, there's a whole range of areas that we can try and understand. We can't be experts in everything, obviously, and it's obvious it needs to be working with teams when you're bringing all these things together. Certainly one of the things that we are observing in the marketplace is really around skills. And I know that Has mentioned this in his closing remarks as well, is it really is a great way of, we know there aren't enough skills in IoT and data and ML. So if that's something that you're passionate about, then really do invest time on skilling up. And there's some tremendous resources. So yes, we've mentioned MS Learn a number of times. I go up into MS Learn daily and discover things that I didn't understand that I probably should have understood. There is so much to learn up there. The certification is a great way. The certification, so AZ 220 certification, just go and search that on the web, and you'll land in the right place. It really does cover off a whole range of different skills that you need to pull together an IoT solution. The other place I would strongly recommend you check out as well is go search for the IoT reference architecture. So go search for Azure IoT reference architecture. It's about a 70-page PDF, and read that. It is absolutely gold, and you will learn a lot, and it'll really help you with trying to think about your solutions. I've heard this come up a couple of times. I think in Jason's session, it's often easy for us to think about like a single device. Okay, I've built my single device, but then how do you scale it out to potentially thousands of devices? And the way that you start thinking about a solution does radically change. And so do check out the Azure IoT reference architecture, because there's a lot in that document that will really just kind of extend your thinking as to the best ways to approach solutions. Now, I think that one of the last things we want to talk about, Val, maybe I'll let you talk about this, is IoT Central, and kind of, I know that Sam George talked about it, but maybe you could just touch on IoT Central again.
Yes, and I think Sam, as we kind of had a chat with Peter around, when you're building IoT solutions in Azure, you have access to all these different various blocks, right? IoT Hub and all of the other services, and IoT Central is a way for you to get past that, and it's our fully managed IoT service. So if you don't really have a lot of time to invest into the platform as a service services and build all of that architecture from the ground up, check out IoT Central. You'll be able to start in just a few seconds, and it has a 7-day trial for free for you to get started. But I know we're out of time, and thank you everyone for tuning in today. And we really hope you enjoyed the session. Just once again, check out our 30 Days to Learning Challenge on aka.ms, 30 Days to Learn IoT, and all the resources will be posted at aka.ms/IoTLP/blog. Thank you so much, and until we see you again, bye.